So good afternoon, everyone, and thank you for being here. This webinar here is brought together in partnership with Microsoft. At the end of this hour, you will learn more about the options that you have to build a better cloud. We truly believe that the partnership with Microsoft is unique in the market, and together with the partnership, we lead the efforts with technology and business to bring programs and innovation to you and the community so that you can build a better cloud. The topic today is unlocking the cloud operating model, focused primarily on the Canadian public sector. Speaking to you today is Marc-André Potrias, who is a senior cloud architect working with Microsoft. Marc-André comes to us with about 20 years of experience, not just working with information management, information technology, but currently with cloud practices. Along with Marc-André, Diego Casati is here to talk about some of the innovations around cloud native computing. His practice is primarily focused on innovative technology, current practices with Kubernetes, GitOps, and something near and dear to our heart, infrastructure as code. From HashiCorp, you will hear from Michael Wood. Michael is the field CTO. He helps organizations understand and bridge the concepts of technology adoption, organizational changes, and overall, we tend to say here at Microsoft that Michael helps us understand the intersection and borders between cloud adoption, technology adoption, and change with his own brand of philosophy that helps us understand what decisions we need to make to build a better cloud. Finally, my name is Gilberto. I am Gilberto Castillo, a solutions engineer here in Canada, together with my partner, Jeff Ewan, worked directly with the federal government to bring you technology options and solutions that help you build a better project, and hopefully with the partnership with Microsoft, help you build a better cloud. So let's get started. We will pass the screen to Marc-André.
Hi, so I'm Marc-André Potrias, and let's talk about some of the questions and concerns I hear from the greater GOC community. So cost optimization. This is a common concern to all organizations. Managing costs can be complex in the cloud. As an example, as people move more and more workloads to the cloud, properly customizing logging for your need is not always top of mind for application teams, and yet can drive a lot of cost.
Hey, Marc-André, it looks like we need your slides. Thank you.
It's not sharing? Okay, one sec. Is this working now?
There it is. It's coming up currently black, but it looks like it's loading.
All right.
You are sharing now. Thank you.
Okay. We have Azure Advisor, the Cloud Adoption Framework, which also known as CAF. We have the Well-Architected Framework, also known as WAF, that can help you optimize costs. When we talk about skilling is a pressing need for everyone. When we talk about skills, we offer various tools and programs that are available to you. In particular, we have the Enterprise Skilling Initiative for your teams to build their cloud skills and use Azure confidently. Security, governance, and compliance is foremost on everyone's mind. We have worked with the greater GOC community to build the Azure PBMM blueprint, the GC Cloud guardrails, and to ensure you start off on the right foot. However, there's still more to do. If you look at the CAF and WAF, we offer very prescriptive guidelines on how to take a holistic approach to ensure you are secure by default using tools such as Azure Policy. You also need to change your approach to security and adopt a risk-based approach instead of focusing mainly on security controls. From an application perspective, you need to include security through the full application development lifecycle. You need to adopt DevOps and automate everything, including security. Think shift left. We work closely with our partners to provide tools and programs and resources that can enable you to automate and deploy secure workloads. With HashiCorp Vault, for example, you can use the same tools to manage secrets and protect sensitive data on-premise and in the cloud. Everyone wants to go faster. For some organizations that are still just exploring the cloud, I see many struggling with the initial planning, from conducting SANA to performing cost analysis and building business case. It can get overwhelming. We have done it many times with JOC organizations. Reach out to us and our partners. For more mature organizations, it's usually more about people and process. How and what to migrate is very important. Should you lift and shift? Should you modernize? Maybe both. You really need to migrate all of your existing applications. Maybe you can retire or replace some applications. Take a look at Dynamics 365 and a Power Platform. You'll be amazed what you can do in a few days. When you have a compelling deadline, you can lift workloads to the cloud first and then modernize them. We have tools such as Azure Migrate, Cloud Pilot, and other programs and resources that can greatly simplify migrating to the cloud. Other times, it's easier to modernize applications on-premise first and then migrate to the cloud. If you're using Kubernetes and containers on-premise, migrating containers is simpler than migrating traditional applications. We have multiple resources and partners who can help you migrate and modernize to speed up your digital transformation in the cloud. And now, let's review your cloud operating model. This is very important. I see many organizations trying to apply what they currently do on-premise in the cloud. For example, many organizations are still deploying changes manually using tickets and change windows. That type of approach is frail and doesn't scale. You need to adopt DevOps practices. You need to automate as much as possible. There are many tools like ARM templates, Bicep, and HashiCorp Terraform that can greatly help you automate everything. Make use of the CAF and WAF guidance and best practices. You also need to review and delegate more operational roles and responsibilities. Implementing Azure policies and guardrails goes a long way to securely delegating operational responsibilities to application team. Migrating at scale. Migrating one or two applications is not too complicated. If you want to migrate hundreds or thousands, then you need a real plan. And we have tools and programs such as the Azure Migration and Modernization Program to help you through the whole journey. With partners, from defining the strategy to making a plan, skilling your team, setting up the environment, moving the workloads to the cloud, all the way to how to secure, manage, and govern your workloads. Azure Migration and Modernization Program works with partners to help you migrate to the cloud with confidence and accelerate your adoption journey. So let's go a bit deeper in some of the tools and programs that I just mentioned.
Hi, Marc Andre. It doesn't seem like your slides have been advancing, just as a heads up. I think they are now, but they haven't for a bit.
Okay.
We're good now.
So we offer a comprehensive collection of guidance, tools, and programs to help address the previous concerns. First, we offer a framework called CAF that offers guidance and tools to help you manage a robust cloud adoption strategy, one that aligns people, business, and technology elements of your digital transformation and sets up a well-designed cloud environment. Second, we have the well-architected framework that offers guidance at the workload level to build and improve the quality of workloads based on architectural best practices. These two key frameworks are based on our own digital transformation learnings and years of experience working with several customers and partners. Third, to provide strong operational foundation for your cloud journey, you need to implement DevOps across your organization to ensure your teams work together securely and ship code and application faster. For that, we recommend that you leverage the above frameworks along with GitHub and or Azure DevOps and make use of advanced DevOps tools like HashiCorp Terraform, Packer, and Vault to help provision and manage your infrastructure. The Cloud Adoption Framework offers the guidance and tools that help you align and implement people, process, technology strategies to adopt the cloud with confidence and accelerate your adoption journey. Built with a modular approach, the Cloud Adoption Framework helps organizations break down their journey into discrete stages with clear guidance and tools for business decision makers, cloud architects, and IT professionals. It is an iterative and cyclical process where organizations jump in and out of stages based on their progress and needs. Now, as mentioned earlier, the CAF helps to deploy compliant, secure, and well-managed cloud environments. However, without well-designed workloads, even well-designed cloud environments will not succeed. The well-designed architected ecosystem offers guidance and tools to improve the quality of your workloads, or in other words, deploy and optimize high-quality workloads based on proven actual best practices. For example, we offer workshops where we'll work with you on reviewing and optimizing your costs. Back to you now, Gilbert.
Thank you. So I believe Diego has the floor.
All right, let me just start sharing here in a second. So good morning or good afternoon, depending where you are in Canada. I'm Diego Casari. I'm part of the Global Black Belt team here at Microsoft. And primarily what I want to talk to you about today are some of the tools, so HashiCorp tools that we use and that I work with my customers, including, of course, GOC, and then how you can actually get some leverage out of these tools and what integrations we have today in Azure. So primarily, if we look at the tools that we are using today, I want to talk about the three probably primary tools that I see my customers using. So Terraform, Console, and Vault. Starting with Terraform, what we typically get out of it, of course, is automating your infra, getting infrastructure as code, and getting a clear view of the state of the infrastructure before you actually apply anything. So before changes are submitted to your infra in Azure, you have a clear view of what's changing, how things are changing, and you can also save that, of course, in GitHub or Azure DevOps. With that, you have a stamp, which I think is quite important. So you know, here's how my, let's say, an AKS cluster looks like today, and that's how it looked like before an upgrade. We typically don't talk, we talk a lot about spinning up and down infrastructure. So here's an example. You can have resource groups, NSGs, the VNets, the subnets all carved out, the Azure firewall. You can have all of that, and you can stamp that. And now you know that every time somebody needs something that the infra team needs to do, it's coming out of a Git repo or again or something like an Azure DevOps, and it's stamping down, and you can essentially have, if you will, like a cookie cutter solution. It's always the same, and the results are expected to be the same as well. What we don't talk about, which you kind of get for free with Terraform, is a disaster recovery option. Take AKS as an example, and this is something I talk day in, day out with my customers. When you use something like Terraform, yes, you get a stamped down version of your cluster, but you also get DR out of that. How? Well, if for some reason you need to spin up a brand new cluster in a different region, you can. All you need to do is to change some settings or some variables, or you can actually have that ready to go on your, let's say, GitHub, and you can trigger a task. And with something like GitOps, now you have a new cluster automated for you in a different region. This is actually quite powerful, and it's something that we keep talking to some of our customers. If you haven't implemented, you should. If you have already, if you're a user of Terraform, this is just a next step that will get you a lot. The other thing I want to mention here is how open, being open source and how extensibility should be taken into consideration. A lot of times, you will have folks sending PRs back to the Terraform provider for Azure to improve it. Whether that's a new feature in AKS or something completely different, say a new service just came online, you will see that. So again, this is also quite powerful because you see it's transparent, and in the spirit of open source, you will see things coming up nicely with folks from the community, yourselves, us as just direct contributors to that, just enhancing this as it goes. So I wouldn't underestimate that. The second component that I want to talk about today is just console. We do have a console service on Azure, fully managed, so you get the benefits of having a service mesh if you want it, or service discovery, which can work with Kubernetes or VMs. So your Linux VMs, you want to use them, or both, without you having to manage everything. You can, console, it's quite simple to manage, but in production, if you want it, I would highly suggest going with something like that. It's a service, you toggle, and then all of the really hard work is done by the SRE team in HashiCorp. And one of the things I want to mention is there is a native Azure experience for all of this. And the reason I put that in there, you go to the marketplace and you essentially acquire it in the same way they've done it before. This is actually quite easy to toggle on and to enable. So the bottom line for me of when you need console is a couple of things. If you need a service mesh or service discovery, so typically folks in running Kubernetes will come along and will be looking or investigating whether or not do I need to have that. If you do, I think this is a great option. Again, that is an SRE team that from HashiCorp. I mean, they know this inside out to help you with this service. So if you're looking for that, highly recommend. The third thing here, it's Vault. And I've been a user of Vault for quite some time. I've used them in VMs, but also probably the majority of time now on AKS. Again, there's a lot of automation you can do in here as well. You can, if you wanted, use Vault and a lot of the things like auto sealing with Vault. You use Vault for that, but you can use Azure Key Vault as a backend. So Azure Key Vault will give you things like HSM. So you need to have hardware modules that will do the crypto. You can, Key Vault will give you that. And then in front of it, you can use Vault, which I think is, again, it's a fantastic combination here. Again, kind of following the same guidelines and ideas, being open source and having the providers and the fact that you can actually do a PR against that, I think it's amazing. It kind of reflects where we are today as an industry as well. So Vault is, these three tools are primarily what I have in my toolbox. Now I want to give you something else to think about, which is Packer. Again, I've been a user of Packer for quite some time. We now have an Azure Image Builder, which is essentially Packer as a service. You can get your Packer JSON files and your templates. I typically test them in my workstations, but when I'm automating, that goes into Azure Image Builder. There's a high level of customizations you can do. So think about if I have to spin up a CentOS or Ubuntu VM, and as I'm always doing a gold image, I can use Packer or Azure Image Builder for that, and have that streamline and be sure that anything that comes out of that pipeline, that image, that VHD in our case, or VHDX, it's always the same. So that having that level of control and customization, I think is also highly appreciated. And Packer is, for me, that extra bonus tool that will give me that. So with this, I'm going to bring it back to our panelists here, and so we can talk about the transition to hybrid cloud. Michael, I think you were up next.
Yeah, excellent. Just need to, if you can stop sharing, I'll pick it up.
Yes, I think you can actually just pick it up in here. There you go.
Perfect, thank you. So very quickly, I'm going to go into just a handful of patterns as we talk through what we're doing from a trust perspective. Assuming you can all see my slides here. Does that look right to everybody?
Yes, we can.
Excellent. Okay, so at a high level, where HashiCorp is really coming in is providing kind of these control planes for doing things like we were just talking about with Diego around bin packing images so that I have kind of a golden image repo that's been fully tested and vetted that I have available to automate the deployment of. I may use something like Terraform to deploy complex distributed systems. I may secure all of that with Vault. I may apply things like networking, automation, policy, authentication, authorization, routing controls with something like Console. But the idea is that HashiCorp has really begun in the early days of just trying to make life easier for practitioners to automate and encode declaratively more and more of the deployment of infrastructure and IT services in general. So think of like identity brokerage across, on and off prem. Mesh type concepts extended beyond the Kubernetes cluster into, bare metal constructs or VMs or whatever is required. So we want to try to provide control planes that sit outside of the technology churn so that we allow technology to continue to move. New platforms are going to emerge, new approaches to continuous delivery. So how do we play in and provide things like good, consistent change management with control, those types of things. And so I'm not going to spend a whole lot of time on each of these slides. My hope is that, by proposing a few thoughts, we can get a few more conversations going. But the key is we know we want to go very fast. We know that when we can go fast, we can become more adaptive in whatever sphere that we're playing in. I can release new artifacts, new applications. I can respond to legislation. I can do all of these types of things if I'm able to deploy and provide self-service and dynamically generate some of this infrastructure so that I can release applications or onboard new applications. And the organizations that are able to do that typically tend to outpace, competitors. Oftentimes at a governmental layer, these pressures are a little bit different when we're talking about foreign actors and/or hackers and so on. But it's still the same general concept. How do we build adaptability into our systems and our ability to respond, audit, and control? And naturally, the faster that we go, however, the easier it becomes for us to kind of introduce mistakes to the system. Gartner would say that, most all of the breachable opportunities are going to come from misconfigurations. We're kind of click-opsing our way to environments, and because of this, something gets left out. Some of these are older. I'm not trying to be, current with all this. I'm just kind of trying to illustrate different patterns. So if we're talking about like the Facebook breach, this was a blob store that was left open, plus a leaked credential. With Cap 1, it was more of like a misconfigured WAF, web application filter, cloud native WAF that was mismanaged, mishandled, along with, kind of leaked credentials. With Target, the retail outlet really didn't have solid networking controls. So attacker was able to come in through the HVAC system on a store and ride the network as a trusted participant all the way back to corporate. And then obviously, a lot more impact to governmental agencies was around sort of supply chain style attacks like the SolarWinds breaches that we saw. And these types of breaches continue to come, various types of supply chains. I'm consuming, third-party code, and what happens if, somebody brings in a writer or introduces some form of malware. How do I detect that? How do I control it? How do I deal with it from a chain of custody standpoint, from a breach management standpoint? And most of what we see around things like FISMA and NIST and these other sort of government standards for the way that we need to prove that we're handling data effectively, that our networking controls are in place, that we're not extending trust to things that we shouldn't be extending trust to. It really goes into dealing with this massive complexity. So one of the reasons why this is so difficult for us to adhere to, kind of cybersecurity standards and or just holistic defense in depth standards and audit and those types of things is because we tend to be hyper siloed. We have a siloed technical team for every piece of infrastructure out there. And so it's very difficult for us to kind of correlate events as they cross between teams because there's no kind of centralization of workflow. I can't tell how an identity that was created was used to gain access to a network device, which was then used to request a credential, which was then used, that credential was then used to create a workload and then sign the workload. And now it's trusted on the network. And now I'm in full on breach. How do I deal with that? Most of the standards that we see coming out are about instantiating best practices to kind of isolate, deal with things like chain of custody, begin to move much more strongly into sort of zero trust networking paradigms, because as this technology kind of portfolio begins to sprawl a bit more, we see the need for something that's more unified. So one of the things that I'm pointing out when I do this kind of a whiteboard with customers is that in the private data center, we have all of these controls, all this castle and moat sort of construct where we sort of trust things inside of our perimeter. We don't trust things outside the perimeter. And so I have kind of different policies for the way that we manage encryption, on network and off network. Progressively, we've tried to modernize this by bringing in maybe Kubernetes or, some other form of paths that we rolled into the private data center. And we find that it has a totally different set of controls that manage that environment that are nothing like what we do in our traditional ITIL, ITSM, VM environments, which is nothing like the way we manage mainframes. And, we have all of these different kind of operational footings. And then as we add in clouds, which bring in kind of their own toolkits and approaches and operating models, it's very difficult for us to control that. If I need to run an audit or I need to understand how, something has passed all the way through all of these systems, where do I start? Where do I finish? How many teams do I have to call? How many audit logs do I have to dump out? It's just sprawling. It's very, very too much, we'll say. And so as we consider how we go about answering this charge, the question that I keep coming back to is, am I adding complexity or reducing complexity? It's great to have like a defense posture scanning tool because I know that I've mishandled something somewhere. So let me have a defense posture scanning tool, which looks at all the open IPs and tries to find breachable opportunities and then allow me to kind of mediate that. But it's not dealing with the root cause, which is a lack of change management controls on provisioning or on identity attestation, et cetera. And so I need to change the way I think about controls. My controls are no longer static IP addresses that never move. It's funny, I was at VMware for a while and Pivotal and in a number of places in the past, Oracle and others. And as we looked at some of these things, we thought that we were introducing kind of more ephemerality to workloads when we introduced VMs. But it turns out that VMs are more long-lived than the underlying hardware platform. Like, let me just use the vMotion to move my static VM over to a new machine. I can retire the hardware, but I can leave the server alone and it can stay static for years and get out of date and patching. And, I have all these things that I struggle with because I'm managing things very, very statically. We want to shift much more into ephemeral infrastructure. As you think of like supply chain style attacks, where there's a phase 2 malware that's been downloaded, being able to restripe environments. I think Diego mentioned that earlier. Is critical. Like, how do I mitigate the fact that I realize that I've been compromised via a patch? Can I target all of that area of compromise and just restripe the entire environment with a known good image that removes that particular threat? How could I detect it? There's a lot of things that kind of go into this, but I'm just going to open up a few ideas for future conversation. Some of what I'm focusing on here is the idea of industrialization. And you'll hear me use these phrases a lot, but I think that's different than automation. I can build automation in all kinds of little pockets. If you're a PowerShell user, you can do automation there. You can write Perl scripts. You can, we used to use Docker Compose, and there's all kinds of things that we can do to drive additional automation. I can hide automation behind platforms. But the idea is that I'd like to have something that's consistent, that's easily understood, that provides things like machined parts. The example that I have here is around the response to World War II, the rise in 1930s, where the president asked for 50,000 aircraft that couldn't be delivered. We had to Basically, we could produce about 300 aircraft a year out of this manufacturing facility. They partnered with Ford, and a lot of what they saw is we have no sense of forward motion. It's just, there's no assembly line. There's no machined parts. Everything is custom created from the ground up. And that's where I leave a lot of difficulty. Frailties in the design can be introduced that way because it's too many hands on deck. So how can I codify and sort of begin to move more towards this sort of automated thought where I fire instruction sets at robotic arms and they produce a result? That makes a lot more sense. It provides me, it limits some of the choice of the development teams because I'm using sort of standardized machine parts, but they're non-differentiating parts, right? I don't want a developer thinking about a WAF. I don't want a developer thinking about the VPC. I want them focused on delivering code which produces an outcome, for a taxpayer or whatever system it is that I'm supporting. Maybe it's health and human services, something where I'm doing something from medical care. Well, how do I protect that HIPAA data? That's where I want you focused. I don't want you focused on perimeter security elements. They're sort of outside of your domain of expertise. Let's build that as think of it as an infrastructure microservice. And when you go to deliver something, you kind of inherit those best practices that the networking team has baked into the automation to deliver that networking device. So if you think through that, I also want to apply things like the microservices thinking to the way that we structure and deploy infrastructure consistently. As you can imagine, these environments can get very, very complex. I don't want to rewrite entire blueprints, if you will, of large scale infrastructure. I want a bunch of composable parts, and I want to invoke them when needed to create an environment. That way, when I do need to make an update to, say, the standards that we apply at the WAF, I can do that sort of globally. I can see where that module is all being used. And then I can, say I want to do some blue-green deploys or restage my development environment to pick up the new changes or whatever. But the only way that I can do those kinds of things and get out of sort of the patch in place, nurse servers back to health, and move more towards kind of immutable infrastructure concepts where I just kind of rip and replace infrastructure when I have a new version, a new image. I have to think in terms of automation. I have to think in terms of audit and control policy. And so to begin with where we do chain of custody and trust, we need to be able to trust our infrastructure has been configured properly. We talked about all these breaches in the past. Tesla was breached because of open Kubernetes. Kubernetes is, I don't know if you're aware, but it's probably the most attacked surface on the planet. Because a lot of people misconfigure etcd and leave it unencrypted or open to public traffic or the services API. There's areas in this system that we need to make sure are locked down and handled appropriately because it is a system that's capable of creating trusted workloads on your network. So how do I control it? How do I manage it? How do I validate that the way that it was constructed, the way that it was automated in terms of deployment meets policy expectation? One of the ways to do that is define the code set, infrastructure as code, and fire it through a policy engine to guarantee that all of our GRC concerns, security concerns, cost concerns have been met before allowing it to touch production or any environment. And so if we kind of break that down, for those who aren't familiar with Terraform, the idea is it runs a plan phase. It says what is out there in the infrastructure. If your infrastructure as code says, I want 10 instances and there's only 8, it will say, this is my plan for adding the 2 new instances. And then I will assign them IPs, I'll name them, I may sign them with a certificate, whatever is required for those 2 instances to come on board, update the load balancer. This is the set of instructions that I'm going to do to make this environment look like what you asked for. And it will produce that plan output. That plan output is what gets passed through the policy engine to say, does this violate our cost constraints? Has this introduced security frailties that I need to be aware of? Like these things I can actually do proactively before the apply phase is called and the new infrastructure materializes. And Terraform is really designed to abstract a lot of the complexity and make it much simpler to work with through our provider network, hundreds of providers, thousands of pre-built modules out there in our public module registry, that you can kind of get a baseline and get started with infrastructure as code and start delivering these assets in a more machined fashion. So now that I have the ability to sort of trust my infrastructure that is configured appropriately, let me start bringing in identity. And I want to abstract this identity away from my development and operators community. I don't want them seeing passwords in the clear. I want that to be sort of a segmented duty where best practices are being implemented on their behalf. Things like time to live on the secrets, things like creation of database accounts, onboarding teams, et cetera. There's all kinds of like interesting use cases around how identity gets managed. When I do build a system or a service and I want to perhaps digitally sign that service to ensure that I know that it's not a counterfeit, I want to define that workflow between Terraform and Vault to run through and say, is it tagged appropriately? Does it meet all of our policy concerns? Have I seen it come through the build process, the acceptable build process, or is this coming out from external? Is it on the appropriate network? I want to ask a lot of interesting questions before I sign that infrastructure and say, this is not a counterfeit. This is a true engine that was built through the appropriate processes. This gives me a lot of that change management that I need to have around identity attestation, my workflow about how do I prove you are who you say you are, and how do I vet that this is coming from the appropriate users, and I'm taking the appropriate actions, whether it's a database secret, whether it's a certificate that I want to manage around signing a web service, whatever that is, I want to handle those secrets centrally with a good, clean automation workflow. It's a lot of interesting things that we can get into here, not the least of which is encryption as a service. Because I have Vault between the caller and the system, I can actually do encryption in flight where the cloud native storage never sees the data in the clear. So if you think about proving to auditors that my data has been, all of my PII information, HIPAA information, if I'm talking about HHS, whatever it is that I need to be managed appropriately, if I'm able to say Microsoft couldn't have seen it, HashiCorp couldn't have seen it, I hold the key, and this is the only way that that information could have been decrypted. Fantastic. You're able to show an auditor end-to-end chain of custody. There's, even if there was a breach on the cloud side or our side or whoever's side, if you're the only one with the key and it's the only way that this thing could get decrypted, you're isolated from those things. You can show chain of custody that it was very difficult to kind of breach that. So there's a lot of interesting things. Obviously, I'm not saying you can avoid all breach. I'm just saying we're trying to tighten those windows and make it very, very hard for attackers, which is what your policy agencies need to see in terms of indemnification, that we're meeting our governmental requirements. Now, once I have these strongly attested IDs, I can then begin to do things like automate the network. And that can be sort of this service mesh approach. So I'm going to use name to base my intention-based routing rather than raw IP controls. Unless I'm doing deep packet inspection, it's very difficult for me to tell what's coming across that IP. All I know from a firewall perspective is that I've got a trusted IP that's requesting access to a backend system. And so typically I allow the traffic. The firewall may prove to be a solid alerting mechanism that something is on the wire that shouldn't be on the wire, but it's not a great policy enforcement engine. So I want to think about firewalls as more detection and less, certainly it'll block untrusted IPs, but it's less about determining if somebody has hijacked that IP other than kind of as an alert. What I'd rather have is these intentions that says, I need the strongly attested name. If that name is correct and I see a policy which says it can talk to somebody else, I allow that traffic to take place. And I'd like to set filters and rules based on that to say, hey, that tax agency has been closed for the last 3 hours. Why am I getting a call for taxpayer information? I need to be able to see that and react to it, deny traffic, because that's not trusted connectivity. And I want to be able to use this for more than just kind of that service mesh concept. The service mesh is where I distribute routing, authentication, authorization, standardized mutual TLS between all of these endpoints. But I can also use console to update my firewalls, load balancers, WAF, SIEMs, whatever it is that I have out there. I have a record of what IPs should be talking to what IPs based behind that name, because I'm health checking. I've registered and I'm health checking all of those various endpoints which support the named services that I'm managing connectivity between. And so I can do things like fire a new config out to Terraform and have Terraform write the new config out to a load balancer. So I get this really dynamic kind of networking footing. And then finally, I want to establish some change management around how we schedule applications and workloads across the fleet. And I'll close right after this and turn it over for the use case discussion. But we really do need to have, an AKS style scheduler or something like a Nomad style scheduler, which separates kind of operations change management from developer change management. So I want to do things like determine that if this is a blue-green deploy, it's a canary build. What am I doing in terms of the application rollout? How do I want the auto scaling to be established? All of that. I want developers to deal with that without having to talk to me as an operator. And as an operator, I want to be able to quiesce traffic off of 10 servers in the cluster and dump them and roll in 10 new ones with the latest patched OS without being disruptive to the end users. And this way I have trackable, policy enforced change management across both above the line and below the line attitudes. And so as we think through the new control planes that we're talking about, infrastructure as code, identity, service registry, and then obviously containers and continuous deployment, the question is going to be, how do we govern this? How do we prove to the auditing community that change management has been handled appropriately? One last thing I'll say before we get off this is, one highly regulated organization that I've been working with will use Terraform to lock down their GitHub environment end to end so that administrators can't come from behind and add users to repos or otherwise violate the process or chain of custody for not only the application that's rolling out, but also the infrastructure, the state files, the networking configs that we're using. All of that is very sensitive, protected information. And I want end-to-end protection for that. And using Terraform to kind of automate the onboarding of the team, the way the GitHub repos are structured, the way they're locked down, secured, encrypted. The teams don't have to ask that question at all. They just consume the automation, and I have end-to-end chain of custody. One of the other things that we're seeing are cron plans at night to validate that my plan has not changed overnight. And then, of course, I would use something like Azure Automation for config management to fire an alert if a change is happening out of band. So if something happens and it didn't come through a Terraform pipe, let me know. I want to know because that's an unauthorized work in this highly restricted workflow. At any rate, hopefully that gives you a sense of kind of how we think through all of these domains and how it's helpful to governmental agencies as we get into things like audit, security, and adherence to standard. I'll turn it back over to you, Kevin.
Yes, thank you. Mark and Dre? Yep, the floor is yours.
So we just wanted to focus, make sure I can share the screen correctly, on some of the best practices based on the cloud adoption framework and well-architected framework.
I'm sorry, you're not sharing yet.
It's slow to share, sorry about that.
Thank you. We can see it.
Perfect. So, so very quickly, here's some of the high-level architecture guidance and best practices to improve the quality of your workloads. And these are based on the 5 different pillars of the well-architected framework. So cost optimization, operational excellence, performance, reliability, and security. A lot of these have relationships to some of what Michael just talked about. I also wanted to highlight when we're talking about skills, we offer many different learning opportunities for Microsoft Learn, but I wanted to put some emphasis on our enterprise skilling initiative where we work with you to, for qualifying customers to offer, a bit tailored training for you. We also have a lot of partners like HashiCorp that offer very specific skilling activities. And we also offer open hacks where we work with you and your team on some interesting challenges. And instead of being instructor-led, it's really user-led, going through a challenge and they have to figure out solutions. And then talking about some of the different programs that we have. One of the key programs we have is the Azure Migration Modernization Program. This is where we work with partners to offer proactive guidance at every stage of your migration journey. If you're looking for simply accelerating faster, we have Azure Fast Track as another program among many others. And then last, I just wanted to focus just a little bit more on the Azure Migration and Modernization Program. That's a proven and unified end-to-end program to help alleviate some of the risks that you get and help you get started on your journey. The AAMP program is available to most of you as GOC users, and it leverages the best practices at every stage of your journey, from defining a strategy to planning, skilling, setting up your environment, and migrating your workload. And this is all based on proven cloud adoption framework and well-architected framework. And it's always in partnership between Microsoft and partners. You get the support for the breadth of migration and modernization scenarios across applications, data, and infrastructure. I know that was a lot to take in a very short time. So here's just a table summarizing some of the use of our fundamental resources that we have and different scenarios of where would you use the cloud adoption framework and the well-architected framework. The key takeaway from this is that by actioning the CAF and WAF, along with leveraging our other resources and partners like HashiCorp, your organization is well on its way to realizing the full value of your digital transformation and migration to the cloud.
Thank you, Marc-Andre. All right, so to close this conversation in 2 minutes or less, we're going to discuss a quick case study. We picked a case study that essentially reflects not just complexity, but also reflects the sort of partnership that we share with Microsoft. One of the ideas here is to think about, some complex regulatory requirements as well as large scale in technology. The Mercedes-Benz Research and Development of North America, MBR-DNA, as we know it, essentially is responsible for creating the next generation of connected vehicles, electric and otherwise, and then the ecosystem that enables them. The thought process behind this is they have this challenging with the technology adoption in that they needed to have applications deployed in mass at its scale, and at the same time being able to recognize where in the landscape of their backend they will reside. The infrastructure that supports this is completely 100% in Azure Cloud. They essentially had a challenge in the scale, meaning we're talking hundreds of Kubernetes clusters being deployed, as well as hundreds of application services being deployed across that landscape. Understanding where the applications resided was a challenge. So they wanted to avoid not just having to find the applications, but also having the control around the application deployments. One of the quotes that we have is, we couldn't have a developer scour the entire environment for days and never find what he or she was looking for. So essentially that led into a path to adopt Consul as a vehicle to improve the efficiencies of the overall deployment. With the adoption of Consul and the introduction of some modern techniques within the Azure framework, they were able to achieve this. And then at the same time, you could do things like accelerate the overall adoption of their services. Two key takeaways from this example, the velocity where they were able to now implement projects from proof of concept to production in a few weeks, as opposed to months and sometimes years of practice and development to be able to support them. The other one here is the significance is in the minutes to be able to discover where an application landed. So instead of carefully planning where to place applications in the landscape of hundreds of Kubernetes clusters, at this point, they were able to free them and based on the automation, create the guidelines that support them and be able to understand where they land, the overall supported infrastructure in minutes. That's one of the key benefits. And in the end, Mercedes-Benz, the research farm and development side, were able to implement this solution and then take the discovery of their services from hundreds of services and then use the platform with greater visibility and compliance. This is a good example of how they were able to achieve this by implementing new technology factors inside of their landscape and take advantage of the expansion frame that Azure Services provides for them. And with that, very quick explanation. This is a public case. You can read more about it in the web. We'll send a link with it. We are open for questions.
Folks, feel free to drop your questions into the Q&A box. That's where we'll be taking them for now.
But everything we said was so well articulated and explained that there's absolutely no questions how to do this in the future. Just jump in and no, honestly, this is so much. There's so much nuance to many of these topics that it's always interesting to dive in on individual pieces and get experience. So looking forward to future conversations if there are no questions this afternoon.